Okay, so good morning, everyone. Welcome to this breakout session. I'm Jean-Vincent Lebet from Nestlé Research. I will be chairing this session, and I have the pleasure to introduce our first speaker, Daniele Girolimetto. Girolimetto, right? Postdoctoral researcher at the Department of Statistical Sciences at the University of Padova, researching on time series, including statistical methods, computational statistics, and modern approaches like machine learning and deep learning. So the floor is yours. Thank you.
So, thank you very much to everybody to be here today. And today I have the pleasure to show you one of my project for PhD and for master. And now that I finished, it's still my project for my postdoc. This is the R package FoReco about forecast reconciliation. So the idea of FoReco is to allow the user to make forecast reconciliation easy. And to start, I don't know how many of you know about forecast reconciliation. So just a very quick introduction to tell you what is forecast reconciliation. It's a post-forecasting process aimed to improve the quality of the base forecast, however obtained, of a linear constraint multiple time series exploiting both cross-sectional and temporal constraints. We will see in detail later about that. So the idea is very simple. We start from some target that we don't know that satisfies some constraint identified by this matrix C. What we have is some base forecast that you can calculate however you want without using the package FoReco. So you can use which model you want. And then, using FoReco, we are going to reconcile them to satisfy the constraint C. So we have a lot of forecasting examples. In this case, we have the famous SKU problem, when we have two sales, we have energy demand forecasting, healthcare, supply chain, but also tourism demand. That is one of the datasets that is implemented also in FoReco, and we will see today. So the R-Package FoReco offers a robust set of tools for implementing forecast reconciliation with a variety of approaches accounting for different constraints. So if you want, you can download the slides also from the app, and if you click on these links, you have more documentation about the GitHub repository and the documentation page. Then something about forecast reconciliation in R. Very easy, so we start in 2010 with the first package HDS that was doing cross-sectional reconciliation. Then the first package that tried to do temporal reconciliation is the TF package. They are no more updated. They're still in the CRAN, but they are no more updated in favor of Fable tools also, that want to try to make in a tidy reconciliation. And, but they still have only cross-sectional for the moment and the probabilistic forecast reconciliation. What we want to do with FoReco is to cover all these frameworks. So we want to cover cross-sectional, temporal, and mixed temporal and cross-sectional using the cross-temporal and looking also to the probabilistic forecast reconciliation. I want to point out that in these days is going out also a new version, that is the version 1.0, that makes a lot of change and broke the previous version. So if you use the previous version, if you do the update, all is changed because we want to a more user-friendly interface and a more fast code. How to do that? Today I will present you this dataset. So the example are using this dataset. That is also one that I use in the vignette that you can find in a website. So the example is very simple. We have a total of 525 time series, cross-sectional divided in a geographical division. So for example, states, zone, and region of Australia. And then we have the division for purpose of travel. So one can travel for holiday, visiting friends and relatives, business, and other. From the temporal point of view, we have a monthly time series aggregated to bi-monthly, quarterly, until to the annual level. So let's start with a bit of notation. This is my academic background, so sorry for this, a lot of academic stuff, but the idea is very simple. A cross-sectional hierarchy is a collection of n variable for which aggregation relationship holds. What does it mean? It means that, for example, in this simple hierarchy, we have T that is equal to A plus B. Starting from this simple representation, we have two equivalent representations. The first one is a zero-constraint representation with the C matrix that we have seen before, but we can still have also a structural representation where there is this S matrix that links the bottom time series to all the variables. The bottom in this case are A and B. So how we can link these two equivalent representations using the linear combination matrix A, and FoReco allow you to calculate this matrix starting from this or for this other approach very easily. So, however, we have the simple case of a generally hierarchical time series, but this is a very simple case. In a practical application, it's very difficult to find this case. Usually, there is more application on a grouped time series where two or more hierarchies share the same bottom and top. This is very important, both bottom and top time series. But we have a more general case, that is the general linear constraint time series. Here you have a simple example where we have two hierarchies that share only the top series. So they don't share the bottom, they share only the top. The idea of forecast reconciliation using an optimal combination is to forecast all the series at all levels of aggregation. So the point one is outside the scope of FoReco. Then, starting from this base forecast, we want to make the base forecast coherent using some least square approach. And this is what FoReco do. The idea, we can use two equivalent point forecast reconciliation formula according to the two structural and zero constraint representation. So we have these two equivalent. They are equivalent. So FoReco gives you the freedom to choose which one to use. Why this freedom? Because as you can see, the computational times is different. So if we don't consider you can see there is two problems in this formula. That is the inversion of the W and this second inversion. In this case, we have only this inversion. So the W is considerably complex, and in practice, we use some approximation form. Some of them are also diagonal. So when we have a diagonal form, this computational time can be omitted. In some sense, when we have to use structural or when we have to use a projection approach, the idea is that when the number of upper time series is going to increase, the structural approach is faster. If the number of bottom time series is increasing, the projection is faster. So how to do that in FoReco? Very easily, we have a simple function that is for the cross-sectional case. It's the notation, we change the notation to make more friendly. So usually the first two letters stand for cross-sectional, and the third and the last part of the function stands for reconciliation. So in this case, we are doing cross-sectional reconciliation, starting from some base forecasts. In this case, I use, if I remember correct, ETS with a log transformation. We have calculated the base forecast outside FoReco, and we give as input of this function this matrix, where the row indicates the forecast horizon and the column are the variables. On the other hand, we have the comb parameter that tell to the function which reconciliation method to use. As you can see, in this case, we have 5 different reconciliation approaches. On the other hand, we can have the residuals if we need to compute the covariance matrix. For example, for OLS and this STR reconciliation method, we don't need the residuals. And then we can choose. You can give to the function the aggregation matrix, A, or just the constraint matrix C, as you can see here. So here we are using the aggregation matrix, and here we are using the constraints matrix. There is no difference. So the approach, so the final results are equivalent. Looking forward, we can see this, the temporal hierarchy has a non-overlapping aggregation of observation of a time series y at regular intervals. Here we have in formula, but I don't want to spend too much time on formulas. So just to give you a brief example, here we have a quarterly time series, okay? Quarter 1, quarter 2, quarter 3, quarter 4. If we sum the quarter 1, the quarter 2, we have the first semester. Quarter 3 plus quarter 4 give us the second semester. At the same time, first and second semester give us the annual level. So here we are not using n variable at the same time index, but we are using one variable at different frequencies. However, all still old. So we have a structural representation, we have a zero constraint representation, and we have also a FoReco function. So also in this case, the notation is very simple. TE stands for temporal reconciliation. In this case, we don't, sorry, too fast. In this case, we have a vector as base forecast. The vector is ordered according to the aggregation level. So for example, here we have all the base forecast for the annual level. Here we have all the base forecast for the semi-annual level until all the base forecast for the monthly level. Then we have the comp parameter, the residual, with the same order of the base forecast. And then here we don't need to pass to the function the aggregation matrix or the constraint matrix, because all is done by FoReco using the maximum aggregation of temporal, maximum order of temporal aggregation. So if we start from monthly time series, the maximum order of temporal aggregation is 12. If you start from quarterly time series, the maximum order of temporal aggregation is 4. Then the input are very easy, and the output is the same vector, so is a vector of the same length of the base forecast vector. So the question is, we have done cross-sectional, we have done temporal. Why we don't do cross-temporal? So what does mean cross-temporal? Cross-temporal, we are going to put together the cross-sectional aspect and the temporal aspect. In this example, I give you a simple hierarchy of 3 quarterly time series. T is equal to A plus B. So on the left here, if you look, we have a node T that is equal to the node A plus node B. But at the same time, inside each node, we have a temporal hierarchy of quarterly data, as we have seen before. We can have also these other representations. So we have a hierarchy for the annual level, a cross-sectional hierarchy for the annual level, 2 semi-annual hierarchy for the semi-annual level, and 4 hierarchy for the quarterly level. In this case, the input of FoReco is a matrix where the row of the matrix is the cross-sectional framework and the column of the matrix is the temporal framework. So we use the 2 dimensions to capture the complete nature of a multiple time series, and any cross-temporal matrix may be constructed from 1-dimensional counterpart. So the input also in this case are the same input that we have seen before, but mix it together. So in this case, our base forecast, as I told you before, is a matrix where the row represents the cross-sectional and the column the temporal. And then we have also the comp parameter, the residuals, and here we can choose between if you want to give to the cross-sectional aspect the aggregation matrix or the constraint matrix, always cross-sectional. And for the temporal part, we can give the maximum aggregation order. As you can see here, the function is very easy to understand, cross-temporal reconciliation. And the output is in the same format of the input. So I will skip some of these because I have no time, but just to be very fast, FoReco don't give you only the optimal forecast reconciliation, but give you also some heuristic from the cross-temporal point of view. For example, here there is a 2-step cross-temporal reconciliation approach proposed by Kurenza Tornasopoulou in 2019, where we are going to do a temporal reconciliation first, and then a cross-sectional reconciliation, and then average of the projection matrix. In FoReco, we can use the TCS, temporal then cross-sectional reconciliation for this order, or we can use the cross-sectional and then temporal reconciliation function if we want to reverse the 2 order. As you can see, the inputs are very close to what we have seen before, but in this case, we are going to have a list for the cross-sectional parameters. So the aggregation matrix and the combination that we want to use in the step 2 is in the cross-sectional list, and the temporal list gives you the parameter you want to use in the step 1. Then we can extend the idea of the two-step to an iterative approach, but in this case, the inputs are very simple, and also if you want to start from the temporal or if you want to start from the cross-sectional, you have a parameter here that you can choose. Then, so, as I told you before, optimal forecast reconciliation, but that's not enough. We provide also classical reconciliation like top-down, bottom-up, middle-out, and also some new level conditional coherent reconciliation approach. We still have some practical challenge and other features, so it's very important sometimes in some practical application to use non-negative forecast reconciliation. In this framework, FoReco gives you two options. One is the optimal solution using a quadratic programming optimization, using in this case OSQP. And the other one is an heuristic, that is the set negative to 0 approach. So we give you also the tools to provide you probabilistic forecast reconciliation using a non-parametric approach. In this case, we are using so this symbol means that you can use cross-sectional, temporal, or cross-temporal using the CS, TE, or CT letters. And we can use a non-parametric approach, mixing the two functions, or a parametric approach, then we just need to sample. So for example, in this case, I'm sample from a multivariate Gaussian distribution, and then reconcile the sample. So in FoReco, in this version, there is also the reconciliation with immutable forecast, and you can use also a subset of temporal aggregation. So maybe you are not interested in all the temporal aggregation, you just need the annual, the semi-annual, and the monthly. You can do that using a vector on the aggregation order. In conclusion, FoReco is a valuable tool for researchers and practitioners in the field of time series forecasting. We provide state-of-art classical and modern reconciliation approach for cross-sectional, temporal, and cross-temporal. And we think that we have done a flexible and a versatile solution for a wide range of forecast applications. So if you are interested, here there is some links. The version 1.0 is only available on GitHub for the moment. I think at the end of July it will be available also on CRAN. And if I can take only 30 seconds, we are also providing you a Howelson forecast reconciliation GitHub repository where we want to collect all papers, applications, software linking to forecast reconciliation. It's still a work in progress. I hope to have time to finish that, but I don't know. So thank you very much for your attention, and if you want to contact me, here we have all my links. Thank you very much.
Thank you, Daniele, for this nice presentation. Pretty complete package, it seems. We have a couple of minutes for questions. Again, a big room.
Hi, many thanks. I have two questions. The first one is with respect to the temporal aggregation. How do you distinguish between flow and stock data? Because that refers to different kind of aggregation. And the second is, say you have interdependencies within your various models that you would like to reconcile. How are these interdependencies between the endogenous variables are somehow factored in when you reconcile the forecast? So I'm thinking in terms of Gauss-Seidel algorithm.
Okay, so for the first question, so the previous version of FoReco was only with stock. But now with this new version of FoReco, we have implemented a new parameter that is called TEW, it's all documented, where you can specify if you want the stock, the flow, or something else. We have, I think, 4 options for these things. For the second question, so forecast reconciliation is usually used for forecasting, not for causality. So it's model free. So it doesn't take into account anything that comes from your model except your forecast and your residuals. So at the moment I don't have an answer to you, but maybe in the future I can have it. Thank you very much.
Thank you. Maybe time for one question. Yeah.
Thanks for your talk. I have a question. So for your reconciliation functions, the input will have the base forecast, the residuals matrix, and maybe some aggregation matrix. So I was wondering, maybe it's hard for users to use that because we need to match all of them to make sure they are in the same order. So is it possible to just have one object, such as like a table object or a list of, for example, hierarchy class?
Okay, so for the moment, no. So FoReco is a, how to say, matrix-based package for the moment, but we want to implement also a tidy reconciliation. So for the moment, nothing is available, but my idea is the future is to provide also some API to use in the Fable or Fable tools, and where we are able to these things for table and some other stuff. Thank you very much for your question.
Thank you. Thank Daniele again for this presentation.